Before we start, I'd like to briefly review two key concepts: causal effect and association. The distinction between causation and association is crucial in research, and in fact, causal diagrams are just a tool to navigate between association and causation. Let's talk about causal effect first. Suppose we have a large population of individuals and that they are all given a treatment. We can then wait and see how many of them die. Suppose 20% of them die. Now suppose we have a time machine that can take us back in time. Now we don't give treatment to anyone in the population. We wait and see that 50% of them die. If we could do this, we would have proven that the treatment has on average a causal effect on death in this population. It prevents death. Of course, in practice, we cannot take people back in time. What we can do is to compare two groups of people that are similar, essentially identical with respect to their risk of death. Quantifying causal effects requires the contrast of the same or very similar populations under different levels of treatment. Formally, we say that causal effects are defined by counterfactual contrasts. In this course, we will not explicitly use counterfactual theory, but counterfactual theory underlines everything we do. If you want to learn more about counterfactual causal inferences, there are plenty of materials available. Now let's talk about association. Suppose we have a population of individuals. Some of them receive treatment and some of them do not. Let's say that 30% of the treated die and only 10% of the untreated die. That doesn't mean that the treatment has a causal effect on death. Perhaps treatment has no effect, but it is given to people who are at a higher risk of death anyway. Yet, we say that treatment and death are associated because the risk of death is different in the treated and the untreated. Quantifying associations simply requires the contrast of two groups of individuals under different levels of treatment. The association may be present because treatment has a causal effect, or because the two groups of individuals are different. So there may be association without causation. We can think about association in another equivalent way. We say that treatment and death are associated when having information about treatment status allows us to predict death better on average, which is precisely what happens in our example. If we learn that someone is treated, then we will predict she has a greater risk of death, even if treatment does not cause death. Causal diagrams are very helpful because they represent both association and causation simultaneously.